Hi Professor Grihalva, this is Ayushman. I'll be demonstrating my graphical user interface for automatically reducing system AMWCO. And for this demonstration, I'll be using this 5-bus system here, and the normal operating conditions are shown in the one-line diagram. So the first thing we do with this GUI is to load the bus data, which is stored in an Excel file, and the line data, which is also in Excel format. We solve the power flow, we do a contingency analysis, and in this box here it tells me that the current AMWC of the system is about 94 megawatts. And I can also view the contingency analysis results in a nice table format where the weakest element is listed first. So now that we know the current AMWCO, we want to reduce the AMWCO by changing generation. So we click on this button here, and essentially the algorithm returns with a lower AMWCO of 3.2 megawatts. Now the most important information is shown in this text box here. So it's telling me that at bus 3 the generation should be changed to 51 megawatts. It is currently 140 megawatts at bus 3, and at bus 4 generation should be changed to 80 megawatts, and generation at bus 4 is already 80 megawatts, so no change is required there. Now the other important information that is shown here is this plot, which is showing essentially how the system AMWCO changes with changes in generation at a particular bus. So this could be useful if, for instance, bus 3 could not be changed to 51 megawatts. Then the user could look at this graph and pick whatever value of generation is required or is available, and that will essentially tell the user what the AMWC of the system will be. So there is no need to run this analysis a second time, because the information is already present in the graph here. Now for this system, the bus 3 has the most impact, and you can see that here in this graph, and the blue is corresponds to the bus 4, which essentially has no impact on the AMWCO. Now this value of AMWCO is guaranteed to be the lowest, because the algorithm actually goes 1 megawatt beyond the value that is shown here, and it sees that there is no change in the contingency overload, and hence returns a value of the value shown here of 51 megawatts. Now the other useful thing that we can do with this GUI is looking at the contingency analysis results. We see that line 1-3 is the weakest element. So in long-term planning, we may want to add a line there, an identical line. So we enter the line parameters in this box here, and we see what effect that will have on the original system, and essentially we get a reduced AMWCO of 20.7 megawatts. So that's the demonstration. I think it's a very powerful tool that should be implemented in real-time operation to improve power system security. That's all I have. Thank you for your time.